Over the past year I've been getting more and more into 3D design. My favourite software package is Shapr3D. This is a professional CAD design package. It is so easy to use, and it is really the one I go for every time. But here I'm creating a simple ball mount for my camera, which will help me do some low profile shots when I'm doing my YouTube videos. So here I'm creating these concentric circles. I'm using the revolve tool here to create this ball shape. And then I'm going to use the trim tool, just creating a cylinder in the top. I'm just trimming away all the lines we don't need. This is a very useful tool. Then using the revolve tool again, so I've created this cylinder around the axis. And that goes on top of the ball, but I need to keep these as separate entities, so I'm using the subtract tool. More rectangle shapes, selecting the area, using the revolve tool again, and this is going to be the plate that the camera sits on. Then use the chamfer and fillet tool, another very satisfying tool to use. It gives a real professional looking result. The chamfer tool creates these bevels, these flat bevels, and the fillet tool creates these rounded edges. It all looks really good. Now I'm going to create the case that the ball sits in, so I use the revolve tool again, and then using the extrude tool to create the aperture. Just using the fillet tool here to create a nice rounded edge. Now what I'm creating here is the dimensions of a brass insert that I'm going to use. And this is the housing for the brass insert. This is an M6 insert. So I'm using the revolve tool again. This goes onto the outer casing. And then we use the union tool just to join these together. Just putting a hole through there using the extrude tool. Then using the fillet just to create these nice rounded joints. Cross section so I can see what I'm doing. I'm creating this sort of plug inside. Now to work on the base. Use the revolve tool again. Then we've created a construction plane on the bottom. I'm now creating the square base. Just zooming out because the base needs to be a bit bigger. So I'm selecting it as 100mm by 100mm. Then putting a 5mm circle in each corner. I'm placing these circles individually, but there are quicker ways of doing this using patterns and things. I've extruded this square to make it three-dimensional, selecting the corners just to put a radius on them using the fillet tool, and then selecting the edges of the holes. I can countersink them using the chamfer tool. I'd forgotten to extrude this bit down, and then I used the union tool to join these two pieces together. I realised I'd missed a bit, so I had to revolve another piece and join that to it. And there you can see this little conical ram thing that goes on the end of an M6 bolt that helps lock the ball in place. So just extruding a 6mm rod in there just to create that space. Rounding some corners, edges, and then assembling it, putting all the bits together just to see what it looked like. But here I've got the ball piece again. I'm creating a hexagon which I'm then going to extrude down into the ball, and that creates this hexagonal hole. It doesn't go all the way through. You can see this is the top, and I just stopped short. And this will lock a bolt in place, a 1/4 UNC camera thread bolt. Now we're using the visualization tools, so we can see what it would look like in different materials. So let's have an aluminium ball, cast iron body to it, just trying different things. Have a gold top, and then a powder coated base. Very useful if you're doing professional design stuff and want to do a presentation. This is Cura. I've sliced the models already. There's 5 models. And this is a Creality Sonic pad I use to control the Creality printers I've got. So scroll down. There's the file I want to print. There's a picture of all the items. This is the Creality Ender 3 S1 Pro. This is the first layer going down. This is the skirt. And this is ASA filament. Several hours later, it's printed these. They all just lift off the PEI sheet once it's cool. And they're looking good. ASA isn't the easiest. That's support material that's just dropped out there. And there's all the parts. So this is the outer casing. This came out exceptionally well. This is the base. It's brilliant for prototyping, really good. And there's the ball. This didn't come out very well on the underside. I would print this in 2 halves next time. And that's the plate that the camera will sit on. That's the little locking ram that will go on the end of an M6 nut. There's an M6 screw. There is the M6 thumb screw. And there's a brass insert. That's M6. And that's a 1/4 UNC bolt which matches the thread in the cameras. First thing is to push that down or up into the ball. Took a bit of persuasion, but it's well locked into place now. And that bit would then sit on there. I won't glue that in place just yet because it's got a thread through this. Next job is to get that brass insert into its recess on the inside. So I loosely position it in there. Then I used that M6 thumb wheel to actually draw it into the hole. I'm screwing this in and it's pulling it into its housing. Put the little circular ram in there, then put the ball in, that locks it into place. All moves, thumb screws in, then I'll push it onto the base. And there it is. Then we use some acetone. The beauty of ASA is you can weld it using acetone. So I'll paint some acetone onto the surface I want to glue or weld. Generous amount. I'll let it tack up so it doesn't run. So I don't want to lock the whole ball joint together. Push that down. And a couple of minutes later it's welded. There it is, all nice and firm and fixed. And then you got the locking bolt. Quick turn of that. And it's all locked up perfectly. Here's my camera on it. All very nice. Works really nicely. So you just loosen that and then tip it down. I've designed this for my low profile YouTube shots and things. I was delighted how it worked. If anyone's interested, it's a Canon M50 mirrorless camera. And I use this for quite a lot of my footage. And there's my finished product. Really pleased with how this came out. All these things are sort of prototypes really, because you can modify them, and I usually do. End up reprinting and redesigning all the while. This is the locking handle. I will design a a better knob for this. This came off something else I'd designed, a light bracket. It still works, it just doesn't look very elegant. It'd be better with something a bit chunkier to get hold of. But very nice, actually moves relatively smoothly, especially when you've got a camera on the top that gives you a bit of leverage, and you can rotate it if you want to tilt the camera up or down, but works very well. Printed this in ASA, and the beauty of that is you can bond it very easily with acetone. So I've fixed this top plate to the ball. You could fix the base, but this does actually rotate. So if you screwed this down, this is a friction grip and it will rotate. But this incredibly easy to design on Shapr3D. Shapr3D is fantastic. You know, it's professional software and it really does a brilliant job. It's very, very easy. I've got other software programs, but this is the one I always go to for my 3D CAD design because of the ease and the speed. Incredibly simple. But there'll be some links in the description. Be sure to check them out, and I'll be back soon with some more videos.